Hi, I'll be doing problem 348 from homework number 2. So the problem states that suppose you first walk 12 meters in a direction of 20 degrees west of north. So this we can call vector A. And then 20 meters in a direction 40 degrees south of west. And this we will call vector B. And then it says, A, what is the component of your displacement in the x direction? So in order to answer that, we can start by drawing out our vectors on an x and y plane. So if we draw our little compass at the top, we know that 20 degrees, 12 meters west of north will look something like this. So this is vector A, 20 degrees. And then using the tip to tail method, we'll connect vector B, which is 20 meters, 40 degrees south of west. So that'll look something like this. And now we know that vector A plus vector B will equal a resultant vector. So from the starting point of vector A to the final point of vector B will give us vector R. Now we know that if we do vector AX plus vector BX is equal to RX, because in order to find R, we have to break up the vectors A and B into the X and Y components. So then we have AY plus BY is equal to RY. So if we draw that on our plane, we will have BX is here, BY is here, AY is here, and AX is here, and then RY is here, and RX is here. Now we know that vector B is 40 degrees south of west, and we have right here a right angle, so we can do 90 degrees minus 20 degrees, which will give us 70 degrees for the inside of our triangle, which will help when solving for A of x and A of y. Alrighty, so we'll start with A. What is the component of your displacement in the x direction? So displacement in x direction. We can look at vector B. So we have the angle of 40 degrees, and we know the length of the hypotenuse, which is 20 meters. So in order to find B of x, we can look at this angle. We know that it's cosine theta. Cosine is equal to adjacent over hypotenuse, which right here we have the adjacent over the hypotenuse, and this is the opposite. So we know that cosine of 40 degrees will equal B of x over the value of B, which is 20 meters. And if we rework that, we will eventually get to B of x is equal to negative 20 meters cosine of 40 degrees, which will give us negative 15.3 meters. Then we can look at A of x. A of x, using the same formula here, is going to be equal to negative A cosine of x, cosine of theta, which will give us negative 12 meters, using the length of A, cosine of 70 degrees, which results in negative 4.1 meters. Also, we're looking at negative values because we're at the left quadrant of the x and y plane, and these leave us with negative values. Okay, so then to find R, what we're going to do is we're going to add AX and BX. So RX is equal to AX plus BX, which is negative 4.1 meters minus 15.3 meters due to the negative value, and that leaves us with negative 19.4 meters. Great, so now we'll look at B. B is asking, what is the component of your displacement in the y direction? So displacement in the y direction. So again, we'll start with B. By is equal to negative b sine of y. And I can show you with A why we're using sine. So if we have sine of theta is going to be equal to the opposite over the hypotenuse. So then if we plug in our values here, we know that this right here is our hypotenuse, which is equal to 12 meters. And we have the opposite, which is AY, which is what we're looking for. So we'll get AY over 12 meters is equal to sine of 70 degrees. And once we rework that, we can eventually get to AY is equal to 12 meters sine of 70. Now AY is going to be positive because we're going up in a positive direction on the plane. Now BY is going to still be negative because we're still going down into negative values. So BY, we're going to do negative 20 meters sine of 40 degrees, and that will leave us with negative 12.86 meters. And this guy leaves us with 11.28 meters. Now to find RY, we'll do AY plus BY, which is going to be 11.28 meters minus 12.86 meters, which results in negative 1.58 meters. Now we'll look at C, which is asking how far are you from your starting point. So because our drawing is a triangle, we can use the Pythagorean theorem. So r squared is equal to rx squared plus ry squared. And then just get rid of the squares by square rooting it. So then we have negative 19.4 meters squared plus negative 1.58 meters squared. And that leaves us with a value of 19.5 meters, which is how far we are from our starting point to the final point of R. And then D is asking, what is the angle of a line connecting your starting position to your final position measured south of west? So for this equation, we can do tangent of theta because we're just looking for this angle right here or this angle right here. Due to the parallel lines, they'll be the same angle. Tangent of theta is going to be equal to ry over rx. Ry, because tangent is going to be equal to sine over cosine. For y, we use sine. For x, we used a cosine. So, plugging in our values, we get 1.58 meters over 19.4 meters. Those negatives will just cancel. And this leaves us with 4.65 degrees. Oh, forgot to take the arctan of that value. We're going to rework that equation to find theta. So then once we do that, theta is going to be equal to 4.56 degrees. And it says measured south of west. So the direction is south of west. And that's the problem.